Hello everyone, welcome back to the another session in design and analysis of algorithms. So today we'll be going to talk about traveling salesman problem using branch and bound. You'll find this topic in 4th unit as topic number 7, the last topic of 4th unit. And today we'll be going to learn about what is traveling salesman problem, and this problem we were solved using other techniques, right? So what are the differences in between backtracking and branch and bound? And also we'll cover one example problem, finding the solution for one example problem. So we'll take textbook problem. So these are the things what I'm going to talk in this video. Now let's get started. So what is traveling salesman problem? Traveling salesman problem is what? You have to find a path by visiting all the vertices of a graph, and the tour has to get finished where you started. Now let's take some example that I'm taking some graph. Now this is the graph. Now what traveling salesman will do is, he wanted to visit all the vertices at least once, right? Now, only once, not at least once, only once. So when he started the journey or tour from starting vertex, which is 1, he can have his tour from 1 to 2, 2 to 3, 3 to 4, and for sure he has to come back to the starting city, which is 1. So this path can be of anything, right? So whichever path is available, that path he'll choose. Now what is the objective of this traveling salesman problem using branch and bound technique is, we'll consider a graph and find the shortest tour and calculate the cost of the tour. So this is what objective of this problem. Now we have to find out the shortest route that is going through all the vertices once and returning back to the starting vertex. So to explore this problem, we'll take state space tree. Now what is state space tree? Let us see that he started his journey with vertex 1. Now he can go to second vertex, and he can also visit third, or else he can visit directly fourth. So this is what actually I told you, branch and bound technique. As far as branch and bound is considered, visiting of the vertices or generating the exploring the node, generating the other node will be always level by level, that is of BFS. So he started his journey with vertex number 1, and he will come to vertex number 2 if he found any path. So as far as this example is considered, he is having a path from 1 to 2. So he is also having a path from 1 to 3 and 1 to 4. These are the possibilities that he can visit 1 to 2, 1 to 3 and 1 to 4. Right? Now, if it is a backtracking, then it is what? He will come to 1 to 2, and from 2 he has to go to the other things, right? 2 to 3, and we'll take the other possibility. As I told you that we'll be going to implement this problem with branch and bound, and it follows a BFS order, level order. So he will go like this, 1. So he's having these possibilities, 2, 3, 4. Now, so we already come across with branch and bound techniques. There are 3 strategies to implement state space tree as far as branch and bound is considered, which are FIFO method, LIFO method and LC method. So I'm going to use LC method, least cost method I'm going to use to solve this problem. As far as this problem is considered, after I have a travel from 1 to 2, from 1 to 3, from 1 to 4, I have to see the cost of 1 to 2, 1 to 3, 1 to 4. Whichever cost I found it is minimum, that node is going to be get explored. Right? Now after I found here, let us suppose that I have found a minimum path from 1 to 3. So 1 to 2 node, 1 to 4 node, I'll not explore. I'll stop exploring these 2 nodes, and I'll start exploring this node. So again I'll explore here. I have already completed visiting of 1 to 3, and what else that 1 to 3 is visited. So I told you in the beginning of this video that traveling salesperson have to visit once, only once. He has to visit all the vertices only once. So 1 to 3 he has finished his visiting. So he can go to 2 to 3, or else he can go to 2 to 4. So now you have to calculate the cost from 3 to 2 or else from 3 to 4, right? So if it is after you found cost in between 3 to 2, you'll get one figure. Let us suppose that is of x, and 3 to 4 he has a cost of x1. So if x is less than from x1, then start exploring the x, because as far as least cost searching method is considered, we have to explore the nodes whichever is minimum. Now if it is found that x is less than from x1, start exploring this node. Fine. So this is what actually objective of traveling salesman problem with branch and bound approach. Now we'll take some example. Now let's see this example. So this is what the graph what I'm considering. 1, 2, 3, 4. So I'm just taking the example graph. Now, so here it is. Now I have given a graph, right? 1 to 2, 2 to 3 and 3 to 4. So according to this graph, I'm generating the state space tree. So as far as the example is considered, he can visit 1 to 2, 1 to 3, 1 to 4. So after he found which is least cost, then that node will get explored. Let us suppose that I wanted to explore using a FIFO method. Then first in first out, we'll start exploring 2 node onwards. If it is last in first out, we'll start exploring the 4th node onwards. So I told you that I'm going to use least cost. So I'll find the cost of each node. Then I'll choose whichever is lesser than all, that node will get explored. So this is what branch and bound technique. Now let's understand the differences in between backtracking and branch and bound in the same example. So backtracking and branch and bound are similar. Both uses state space tree, but the approach is for solving a problem is quite different. Now let's see, the first difference is what? The order. We'll write fresh slide so that you people can also have a note, because as it is an important question for examination purpose, end semester examination purpose. So you can have a question differences in between backtrack and branch and bound with an example. You can take this example, so that the graph what I have drawn just before that, the example you can take and you can start explaining like this. The first difference is what? The level, the order. So backtracking uses DFS. What is DFS? Depth first search. In other sense, you can tell it is an pre-order. That means it visits 1 to 2, 2 to 3, 3 to 4. When? If it is a backtrack. Let's see. So after it came to 1 to 2, 2 to 3, 3 to 4. If it founds that means if the traveling salesperson wanted to take the other path, it will get backtrack. From 4 to 3 backtrack, 3 to 2 backtrack, and he can change his decision from 1 to 2 to 2 to 4, or else he can go complete backtrack to 1 vertex. Now he can change his decision and he can come to 1 to 3. So again 1 to 3, 3 to 2, 2 to 4. It is one of the solution, right? Now again he can change his decision 1 to 4 and 4 to 2, 2 to 3. And he can change his decision 1 to 2, 2 to 4, 4 to 3. He can go in order of depth first search, right? So this is the first difference. And the second difference is, as far as backtracking is considered, every node is a solution. This node is a solution. All the leaf nodes in backtrack is a solution. So that's what backtracking will take more time. It is a time consuming method. We don't want all possible tours. We want a tour which is minimum. So we will find cost of all possible paths and we'll consider the minimum one. And let's see about branch and bound. What is branch and bound? Branch and bound is a technique. It is also for optimization problem, but the optimization problem is minimization. Now, So it uses BFS, that is of level order. So what is the level order? Now he can start his traveling or tour from 1 to 2 and 1 to 3. He'll not go to this path, the path which is visited in backtracking, that it is not the path of branch and bound. He'll go 1 to 2 and 1 to 3 and 1 to 4. Then he come down to the next level, which is 2 to 3, because he already completed his tour from visiting of 1 to 2. So now he can visit 2 to 3, or else he can go to 2 to 4. So level by level will complete in this branch and bound. For every node we'll find the cost and we'll consider the minimum. So we'll find the cost of all and we will be choosing the whichever is having minimum, and all other nodes will kill when the cost of a node is greater than the upper bound. Let's see, upper bound cost is something like 32 and you got all the cost as something like 45, 55 and now the figures. Then the 32 is minimum and 45, what you get the solution is 45, and that was the maximum than 32. So as it is a greater cost of this 32, you have to kill it. Okay. Now let's suppose this is of 25. All are greater than 32. 45, 52, 46, something like 38, something like 39. So among all this, which is minimum cost? This 25 is the cost. So what is the path? 1 to 2, 3, 3 to 2, 4 and 4 to 2, 2. So this, and again back 2 to 2, 1. That is 1, 2, 3, 4, 2, 2, 1. This is the path he has visited for the cost of 25. So what about all these solutions will kill it? Will kill if the node has the cost in this level 38, will kill here. If the cost is more here, will kill here itself. So using the bounding function, what is bounding function? If the cost of the present node is greater than the upper bound of state space tree, will kill the node whichever is producing more cost. So that is what bounding function. So these are the main differences in between backtrack and branch and bound. Now let's see the example. So this problem I have taken from the textbook. So this problem will be going to solve it. Right, now it is one example problem. So this example problem is what? It is a connected graph and it is a weighted graph. And these are the weight or these are the cost from path. Now the cost of 1 to 2 is 20. The cost of 1 to 3 is 30. The cost of 1 to 4 is 10. Like this you have to assume. Now, so what we are looking for? We wanted to get the minimum cost. Now for this what we will do is, we'll find out the cost of the matrix first of all. So cost of a matrix in traveling salesman problem, applying branch and bound. The procedure is different. The procedure is what? We'll reduce the matrix. How will reduce the matrix? We'll find the minimum value in the row and we'll subtract each value with this minimum value. Let's see how it will be calculated. What is the minimum value in this row? 10. What is the minimum value in this row? 2. What is the minimum? 2. What is the minimum? 3. What is the minimum? 4. Right? Now, so reduction cost of this matrix or reduced matrix is what? You have to subtract this minimum value from each element of first row. Right? Now, let's see what is that. Now the matrix is going to be infinite. 20 minus 10, 10. 30 minus 10, 20. 10 minus 10, 0. 11 minus 10, 1. So remaining elements you can write as it is. Okay. Now that is 15, infinite, 16, 4, 2, 3, 5, infinite, 2, 4, 19, 6, 18, infinite, 3. 16, 4, 7, 16, infinite. So this is what? Reduction in minimum, first minimum value of first row. Now, again you have to do the same thing for column. So what is the minimum values in each row? That you please write over here. I'll tell you what to do with this. 2, 2, 3, 4. These are the minimum values which we subtracted each element of rows. Now let's find out the columns also. What is the minimum column value here? 3. And here it is 4. and here it is minimum is 7, here it is 2, here it is 1, right? Now, so after you found it, acha, okay, so this is not the matrix because you have to subtract even these values, right? So that's what 15 is 15. Now no, it is not right. You have to take the other way, that 15 minus 2 you have to go ahead. So now this matrix I'll write again, subtracting the elements. Now consider now reduction cost is what? Find out the minimum value in the row and subtract it. So it is 10 and it is what? 2, it is 2, it is 3 and it is 4. Okay, now subtract 10 in this row, subtract 2 in this row. So if you do so, your matrix is what? Infinite, 10 in 20, 0, 1, 13 infinite, 14, 2, 0, 1, 3 infinite, 0, 2, 16, 3, 15 infinite, 0, 12, 0, 3, 12 infinite. This is what your reduction of row. Now reduction of column also we have to do. For that, write the minimum values in the column 1. So minimum is 1, minimum is 0, minimum is 3, minimum 0, minimum 0. So here what are the minimum values? 10, 2, 2, 3, 4. Add all this together. So this value is 21, this is 4. Finally it is 25. Reduction cost is 25. Reduction cost is 25 and this is what your reduced matrix. Now what we are going to do with this? Now what we are going to do with this is, you are going to find out the state space tree. So what is your state space tree? Tour starts with one vertex. Now he can visit 2 or he can go to 3, he can go to 4, he can go to 5. So as far as this example is considered, make sure that these are node values. That is 1, 2. Second node is what it describes, the path from 1 to 2. Third node describes the path from 1 to 3. Fourth node describes the path from 1 to 4. Fifth node describes the path from 1 to 5. Now you have to find out the cost of 1 to 2, 1 to 3, 1 to 4, 1 to 5. And whichever cost you find it is a minimum, start exploring it. And whichever cost is maximum, that the nodes will not get explored. Now find out the cost of each one. That means find out the cost of 1 to 2. Now you have a question, you may have a question that 1 to 2 cost is already given in the matrix. As far as you see this reduction matrix, 1 to 2 cost is what? 10. So 10 is already there. Then what is the reason of finding again cost? Yes, because we wanted to get the minimum cost, reduced cost. The formula for reduced cost, if I wanted to find out the cost of 1 to, cost of 1 comma 2 is equal to cost of 1 comma 2 plus reduction cost R plus R cap. Now this reduction cost of what? C1 comma 2 again. That is C1 comma 2 you already have. What is C1 comma 2? It is 10. So what is reduction cost? It is 25. If you have any reduction, this R cap value, you have to find it out. How can I find this R cap value? If I wanted to find the path of 1 comma 2, cost of 1 comma 2, make first row infinite, second column infinite. Now again apply reduction. Yes, now we'll see how it will. If I find out the R cap, that is R cap 1 comma 2, reduction cost for this. That means I am calculating second node value, second node matrix. So second node matrix reduction cost is what? Make infinite of these values and make infinite of this value. So 1 comma 2 and 2 comma 1 is the same cost. If you find here 1 comma 2 and 2 comma 1, it is the same, right? So you have to make what? Infinite. That means first row will get infinite, second column will be infinite, and this 2 1 also infinite, and all are remaining same values. So these values, after you found this matrix, you have to find out the minimum value again, and the procedure is same to find out the reduction cost. After you find the minimum value, subtract this value with each element of the row, and after you find column 1, subtract each value with this column 1. So then you'll get one matrix, right? That is what? Second matrix. So that the cost you have to find it out, right? Now let's see. So after you reduce, this is the matrix, and state space tree is this one. So now what we'll do is, we'll be going to find out cost of 1 comma 2. So what is the cost of 1 comma 2? Let's see how I'll find C of 1 comma 2. C of 1 comma 2 is C of, from the adjacency matrix, C of 1 comma 2 R plus R cap. So C 1 comma 2 is what? C 1 comma 2 is 10. Plus reduction cost is 25. Now this R cap value you have to find it out. Now find out the minimum value from this matrix. What is the minimum? This is 0, this is 0, 0, 0, 0. And here minimum is 0, minimum 0, 0, 0, 0. That means no minimum, hence it is 0. So 1 comma 2 cost is 35. So right over here, C is equal to 35. Now again calculate 1 comma 3 cost. Now what is 1 comma 3? As far as R cap is considered, now we will be going to make first row is infinite, third column is infinite. Now after you found first row, third column, after you make first row infinite, third column infinite, find out the minimum value from each row, from each column. So whichever node is having minimum, that will write over here, right? Now, so after you have all zeros, you please subtract the values, right? Now you will get the cost something like, so C of 1 comma 3 is equal to, C of 1 comma 3 is equal to 17 plus 25 plus 11. So the cost is 53. So right over here 53. Now again find out C of 1 comma 4 cost. So if you find C 1 comma 4 cost in the same procedure, so these are what the values, and I'm just writing directly because I have explained you the procedure what you have to follow. So you please follow the same procedure, hence you will be getting the cost of each one. So this is the way. Now look at path 1 to 4 is what? First row should be infinite and fourth column should be infinite, and 4 to 1 should be infinite. The same is follows in all the cost. That means cost 1 2, cost 1 3, cost 1 4, cost 1 5. After you get all this cost, whichever cost is minimum, that path is going to be explored. Now, so among this, what is the minimum? 25 is the minimum. Now again we'll be going to explore from 4. Already tour has completed from 1 to 4. Now what you have to complete? 1 to 4 is finished. Now he can go to 4 to 2. That means it is what? Node number. Let's assume node number 6 is 7. 6 8. Now take this as 7. Now so 6 node is what describing? He is visiting from 4 to 2, from 4 to 3, from 4 to 5. So now find the cost of 4 to 2, 4 to 3, 4 to 5. So again what you have to do? Now 4 to 2, right? Now that node you have to make what? Infinite. First and second and fourth infinite. So you'll get a cost. Apply the same procedure, you'll get a cost. Now these are the cost: 28, 50, 36. Which is minimum? 28 is minimum. Start exploring it. So what he visited? 1 to 4 is finished, 4 to 2 is finished. Now what he has to visit? Again he has to visit. Now node number 9, node number 10. So 1, 4, 2 is done. Now he has to visit 3 and 5. Now find the cost in between these two. Now we found the cost applying the same formula. It's 52 and 28. 28 is the minimum. Now there is only one node which is left, which is 3. So I wrote directly the cost of it. Now point to be noted very clearly that the upper bound we were taken as infinite. So once you got the cost of it, we'll be updating that 28. As far as knapsack problem is considered, we were updated at each node level. So in traveling salesperson problem will not, because the tour has not finished. That is the reason why we will not update that upper cost. Once you find the final tour, you will be updating it. Now according to the bound function, the cost of the solution, if it is greater, if it is greater, all the node values are greater, then we'll be applying the bound function. So 35 is greater than 28. Now kill it. 53 is also greater than from 28. Kill it. So we are not going to kill this 25 because this is the final solution. The path which I am considering is the final solution. So apart from this cost, all other nodes will get killed. So now the final cost of the tour is what? 1 to 4, 4 to 2, 2 to 5, 5 to 3, 3 to 1. So with the cost of 28, he has visited these vertices in this order. So this is about traveling salesman problem. Thank you all.